Good day. In this video, we will be presenting a model related to the field of information and communications technology. Specifically, it is a modified model based on the von Neumann architecture of a computer. Our presentation will be divided into 4 parts as follows. To start, we must first know that a computer is a programmable device that can automatically perform a sequence of calculations or other operations on data once programmed. Therefore, a computer system is a basic, complete, and functional hardware and software setup with everything needed to implement computing performance. This is our device model. We call it the computer block system model. It is named as such because it processes progress in a blockwise manner. We can see here that there are 4 main blocks in color black outline representing the 4 main components of this system.
The system can be divided into 4 main parts, with the first part being the input unit, whose main function is to take the data given by the user. The second part is the central processing unit, which serves as the brain of the computer as it controls all the tasks the system receives. This section is composed of 2 parts, the control unit and the arithmetic and logic unit. The memory unit is the third part of the system, and it functions as the storage unit of the computer. Data can be stored temporarily in the main memory or permanently in the auxiliary storage. The final part is the output unit, which displays the processed data in a readable format for the user.
The general system flow of a computer system starts with the user using the input devices of the computer. These are the following steps or processes. First, the user or the person will utilize the input device of the computer. Then, the input device will send the user to the central processing unit and will be treated as data or information for the rest of the flow. Then, the information will be delivered to the control unit from the main storage. The control unit will execute the most efficient method within its set of algorithms programmed to it. Then, the control unit will now use of the ALU or the arithmetic logic unit to operate those instructions. And those processes will be executed or stored to the main memory. The output will be presented to the form that the user wanted to, maybe a visual or an audio output. Then, the control unit will now decide whether to put the data into the secondary memory based on the user's input data and the algorithm it is programmed to. To better understand the flow of the computer system, here we now go back to the block diagram. So we have 2 types of flow. We have the control flow and the data flow. So the control flow is where the flow of the commands of the control unit. So we have these broken lines. And the data flow is the flow wherein the data is going to. So the data only goes to the input device, to the main memory, to the ALU, to the secondary memory, and to the output. For an example, let's just say the user presses the letter K or wants to type the letter K. So the input device will be the keyboard. So as the user presses this button, the control unit will now take note of the data that the user wants to. So this data will now be stored to the main memory. Now, once it's stored in the main memory and the control unit takes note of it, the control unit will search its most efficient method to execute this operation. So once it knows the most efficient method, it will now use the ALU. So let's just say the most efficient method is binary operations. So after modifying this data, it will now go back to the main memory or go to the auxiliary storage. Then it now will be outputted that the user wants to. Let's just say we're typing a document and then the letter K will appear. So the secondary storage is used at certain times wherein the user wants to save a file to an external drive.
These are the key takeaways from our discussion. For number 1, though human users may be involved, the main process within the system is still non-living in nature. For number 2, an example is the memory unit, which acts as storage. So individually, it can aid in keeping the data that needs to be processed and the resulting information. However, it cannot generate its own data. So over time, the memory unit on its own will be inactive with no information coming in and going out. Next, since the system is linear, all parts will affect each other. A change in the input will cause a change in the processing unit, and so on, or vice versa. Lastly, each part can affect the whole system. However, this linear system heavily relies on the input. The earlier example in number 3 depicts a well-functioning system, but over time, errors can possibly occur depending on the component's condition. Also, as the computer gets old, the quality of the components can decline, affecting its operation.